So everybody's opening to page 23. We'll take our quick look at the calendar. Today we are going to do some more work with radicals. Surprise, surprise. It's our third day in a row on radicals. And then over here it says products of binomials. So that will look like a very completely different topic than any that we've studied before. And then next class we'll talk about factoring, which is an important skill for us. And then one more day on factoring before our quest. So the quest is coming up November the 5th, which is a week from today. Right, so our next quest is 1 week from today, and if you hunt around in the packet just a little bit farther into the packet, you'll see the same kind of practice problems for quest number 3, and there are videos on YouTube, all the same resources we've had the whole semester. Just want to highlight though that even though the quiz is coming up a week from today, it's actually only on the material from classes 19 to 23, and today is class number 23. So even though we have 2 more classes before the quiz, the material from this coming Friday and Monday is not on the quiz. So at the end of today, that's the end of the material for the quiz. Questions on the calendar? Okay, so let's jump to the top of page 23 here. Oh yeah, sorry, put the folders out. Top of page 23, can we go back to Kayla? Okay, so the quadratic formula, raise your hand if that sounds familiar, that phrase, quadratic formula. Anybody think they know that big old formula? Might have been something you've been asked to memorize in a previous class. Big fraction, negative b, plus or minus, a lot of stuff in it. So we're going to see it soon enough officially. But for right now, I'll just show it to you. It's right here. It says negative b plus or minus square root of b squared minus 4ac all over 2a. So at the moment, that formula has no context for us. But today, what we're interested in seeing is the ability to simplify things that came from that formula. So I'm going to give you stuff like this, negative 16 plus or minus root 128 over 8, and I'm going to tell you stuff like that is going to come out of that formula, even though the formula doesn't have meaning for us right now. So our job is to be able to simplify stuff like that. And then when we actually get to that formula officially in a few classes, we'll be able to simplify it because we're simplifying them today. So here's an example, lots of details in this long equation. So starting with negative 16 plus or minus root 128 over 8, that's the beginning of this problem, and we want to reduce that thing. So one of the things we saw was that you could simplify stuff like the square root of 128. Now, our perfect squares are right above my head. Is 128 a perfect square? No. But there's going to be a number maybe that goes into 128 that is a perfect square. And so, for example, we could start with this 2 squared, 4. Does 4 go into 128? It does. But let's see if we can find anything bigger, because if you find the biggest thing that goes in, then you will make the problem as short as possible. So does 9 go into 128? I don't know. You might know, you might not. You have a calculator that can test it. I think it doesn't. Does 16 go into 128? So we just kind of keep playing this game one at a time. So does 16 go into 128? It does, but let's keep pushing our luck and see if we can find anything bigger. Next one is 25. Does 25 go into 128? Definitely not. We can look at that number and know that it doesn't. Next is 36, 49, 64. 64 is the biggest number in this list that goes into 128. How many times does 64 go into 128? It goes in twice. So we take this 128 and we break it up and write it as 64 times 2, right? And then we know that we can split this up as square root of 64 times square root of 2, yes? It's one of our properties that radicals are nice when there's multiplication involved. And then the square root of 64 is really 8. And the square root of 2 we can't do anything with, so that's how we go from root 128 to 8 radical 2. And then we take this fraction, the entire thing is a fraction with a plus or minus in the middle on top, and we split it up into 2 fractions. So do you guys buy that negative 16 over 8 plus or minus 8 root 2 over 8 is exactly the same as this thing? You know, we're allowed to split fractions up when they have addition or subtraction on top. If that is troublesome to you, then let me give you something like this. X over 5 plus 2 over 5. How would we combine those and make one fraction? Just x plus 2 over 5 because it has the same denominator already? Yes? So we're really comfortable going that direction. We have less experience going the other way, but it still works. If you see x plus 2 over 5, you could split it up into an x over 5 plus 2 over 5, right? And so that's all that we're doing here is we're splitting this thing up into two fractions. And then finally just reduce the two fractions independently. So negative 16 over 8 is negative 2. And in the next fraction, the 8's cancel. And you just get root 2. So negative 2 plus or minus root 2 is the simplified version of the original negative 16 plus or minus root 128 over 8. Any questions on that process? It might seem intimidating at first, but it's always the same idea every time, is that you simplify the radical if you can, and then you split it up into two fractions and you simplify the fractions. So we'll give you lots of practice with that today. And now let's move on to number 2. Can we go to Alex in the back? Okay, so taking a look at this first guy, x plus 2 times x plus 3, we're going to multiply this out. And the key idea here is the distributive property. Everything in the first set of parentheses distributes to everything in the second set of parentheses. So this x gets multiplied by that x, and this x also gets multiplied by that 3. And likewise with the 2, it comes in and hits everybody in the second set of parentheses. And so if you had Sandy or me for 095, then you recognize that kind of picture looks sort of like a lobster claw, yes? And so we call it the lobster claw method. So we're just going to multiply according to the lobster claw, and then we'll combine like terms. So the first thing is x times x. What is x times x? That's x squared. And then the next thing is this guy right here. So it's x times 3, which we'll just write as 3x. And it's a positive 3x, so I'm going to make sure I'm clear that this is addition. It's not everything multiplied. And then we're going to do these inner terms here. 2 times x is just positive 2x. And then finally, 2 times 3 is positive 6. And then we just combine these two terms in the middle. 3x plus 2x is 5x. So there's our final simplified answer. No, that's all we're doing for today. Next class, to give you a sneak peek, I'm going to give you something that looks like this, and I'm going to say, can you write it as the product of two things like that? So we're going to go the other direction next time. That is much harder. Okay, but I promised you another method. So that was the lobster claw method. So there's also this thing called the box method, and the box method involves drawing basically a square with 4 smaller squares inside. And then along the top and the left, we're going to put the two things that we're multiplying. So I'll put x plus 2 up here and x plus 3 over here. Doesn't matter which one goes where. And then to figure out what goes in each part of this square, all we do is we multiply the two things that are kind of nearby. So this x gets multiplied by this x and gives me x squared. And then the next one, I'm going to take this positive 2 and multiply it by that positive x and get 2x. See if you can fill in the bottom row there. So we're just multiplying the two things that kind of make each smaller square. So what goes down here? 3x is good. And then I think I have one more color. What else do I have? And then this 2 multiplies by this 3 and gives me 6. And so those are the exact same pieces that we had when we did the lobster claw idea. X squared, 3x, 2x, and 6. And so you just write it the same exact way. I won't write it again. It would just be copying what's up there in blue. Okay? So you can choose. either the box method or the lobster claw method. Or if you like the acronym FOIL, you can use that too. You guys recognize the acronym FOIL? First, outer, inner, last. I'm not a fan of FOIL, so I'm going to try to avoid using that word as much as I can. But if you like FOIL and you're comfortable with it, then do that. You'll get the same answer as we have here. So what I'd like you to do now is work through B, C, and D, and then we'll come back together for just a minute at the end. So multiply B, C, and D and check your answers with your neighbors, and then we'll come back together. Okay, so let's come back together. We've got our three products written out. I said next class we're going to go the other direction. I'm going to give you one of these things I've written in black and ask you to figure out where it came from. What two things did we multiply together to get the thing that I give you in black? And like I said before, I promise you that is a much harder process than the multiplying out. Now, some of you are like geniuses when it comes to multiplying these things out. And we need all of you to be geniuses when it comes to multiplying these things out. Because if you can't multiply them out, you have no hope of going the other direction, which is much harder, okay? So if you have any questions about multiplying these things, you got to speak up. Raise that flag when I'm walking around, because we need to get really good at multiplying so we have some hope of doing the harder direction. And last thing we'll do together is here at number 3. It says we're going to look at the answers that we've gotten here and describe some patterns. And we're going to try to be general so we can use these results even when the numbers change. So for example, what do you see that's the same in all 4 of these answers? The blue and the 3 black things here. X squared is the same in all of them, right? So X squared is the first thing in all of them. And there's a 6 at the end of all of them, right? Sometimes positive, sometimes negative, but it was always a 6. Why was it always a 6? Yeah, the 2 numbers that gave us 6 in every problem were 2 and 3, right? So sometimes it was +2 + 3, -2 - 3, maybe 1 plus and 1 minus, but it was always 6 because of the numbers 2 and 3. So I'll say the last number in our answer, which I'll put in parentheses here, it was either 6 or maybe -6, came from multiplying the 2 numbers in the parentheses. And I'll just put the specific numbers from this problem were 2 and 3, possibly with some negative signs floating around. So that 6 came about because we multiplied the 2 numbers, right? In each of the parentheses, there was an X and a number. And when we multiply those 2 numbers, we got the thing that came last. And it was true even paying attention to the signs. For example, how much is -2 times -3? That's the +6, that's why we got that. But how much is -2 times +3? Is -6, which is why we got that. So it works every time. We're just multiplying those 2 numbers, and there's nothing really amazing about that fact, just pointing it out here. And then the tougher part is the thing in the middle. We've dealt with the x squared, we dealt with the 6, which might be negative, but this is a -5x, this is a +5x, and then, okay, fine, but then we get this kind of really strange looking just x. Like the 5s were the same as each other, but all of a sudden out of nowhere comes this x. Alex? Yeah, so where does that +5 come from? Just looking in here. It is 2x + 3x. But can you just look in here and tell me where the 5 comes from? It's 2 + 3, right? That's the 5. And the fact that there are x's tacked on at the end doesn't do anything. It's really just fundamentally adding 2 and 3 and getting 5, and then sticking an x at the end. What if we try that same idea here? What if we add this number and this number? What do we get? We get -5. Is that the number that was tacked onto the x? Yes. Okay, let's keep on trucking. Add this number and this number, and it's +1 with an x next to it. And if you add this number and this number, there's -1 with an x next to it. So I think we've found our pattern. We figured out where that thing in the middle comes from, like fundamentally, just by looking at the original numbers in the parentheses. I think we can just say, oh, hey, we just have to add the 2 numbers up and then tack on an x at the end. So the last observation here, let's number these guys. So there's number 1, there's 2, and then the last one here is if we add the two numbers, and we just tack on an x to the sum. Just add the two numbers and then stick an x right at the end. So I'm just going to make up one quick example, and then you'll do the activity starting on the next page. I'm going to give you something like this. X minus 5 times x plus 3. So just copy that example, but don't actually do the multiplying. We're going to try to do the multiplying just by using our observations as opposed to actually thinking about the multiplying. So our first rule says what comes first? X squared. So we're going to put an x squared first. Let's take care of the thing at the end, the last thing. So where did all these 6's come from? What did we do? As we multiplied the two numbers, including the signs of those numbers. So we are going to multiply two numbers and stick it right here. What are the two numbers we're multiplying? Yeah, it's -5 times +3. And that gives me -15. That's going at the end. And then the trickier part, the more complicated part, was the thing in the middle. So what are we going to tack on to whatever we get? Yeah, so we're going to do this -5 plus 3. We just add the two numbers up, and that gives me -2. And then what do we tack on at the end? X. And that's the answer. Now, I'm not saying this is better than the box or the claw or foil. In fact, in some sense, it's worse because we're just kind of saying these magical things and not really thinking about why they work. But again, we're trying to prepare for next class where we have to go the other direction. And in order to go the other direction, we really do need to understand these kind of shortcuts that work when we multiply. Okay, so I'll try something a little bit different just at the start of the activities here. I'm going to give you a very broad brushstroke look at what the activities are. We'll see if it's helpful to you. In the first part of the activities, you are going to go the other direction. I'm going to give you something that's already been multiplied out and ask you to come up with two things that we can multiply together to give you that thing. First one has been done for you, but you'll do 3 others. And the next part, there's this big old table. And in the big old table, the idea is to simplify the radical. So I'll get this one started for you. 75 is not a perfect square, but 25 is. And so the first step would be to write 75 as 25 times 3 and then continue that way. So you're going to just simplify those single radicals there. And then on the next page, you get to chart around the middle of the page, which looks like the first things that we did, these really messy things that came out of the quadratic formula. And for these, you're going to follow the same process that we followed for the very first example, which is typed out in all its detail a couple of pages before. Okay? So raise the flag if I can help. Let's see if we can get through the activities.